Mendelif's periodic table. Mendeleev arranged elements in the vertical columns known as groups. They were total 8 in number, right from group number 1 to group number 8. And horizontal rows he named as periods. You can see there in the periodic table. Right from 1 to 12 rows are there. Due to this, he got the small cells. In each cell, he placed one element in such a way that elements were arranged in the increasing order of their atomic masses. He started from hydrogen. He placed hydrogen in the group number 1. Then, second period started with lithium, then beryllium, boron, carbon, nitrogen, oxygen and fluorine. Then in the third period, you can notice here in the third period, group number 1 element starts from sodium. Sodium, magnesium, aluminium, silicon, phosphorus, sulfur and chlorine. Again some places are empty. And this way, period by period, group by group, you can observe the elements arranged in a well mannered. Here, you can notice some important features. First one, the combination of elements with hydrogen and oxygen. In the group number 1, 2 and 3, you will see all the elements are combining with oxygen and form the oxides. While that of group number 4, 5 and 6, elements are combining with both hydrogens as well as oxygen. Means they are forming hydrides as well as oxides. And in the group number 8, all the elements are only reacting with oxygen. There are some vacant places in the Mendelif's periodic table. In some of these places, atomic masses are seen to be predicted. Can you tell me which these elements are? And what are their atomic masses? Right. Their atomic masses are 44, eka boron, 72, eka silicon and 68, eka aluminium. It means that in Mendelif's periodic table, he predicted that in these vacant places, shortly in the coming days, elements will get discovered. And he also predicted the possible atomic masses and the properties of these elements. And surprise, dear students, after few years, the same elements got discovered and properties were also matching with that of mentioned by Mendelif. Let us have a look to the table which is mentioning actual properties and predicted properties by Mendelif in his periodic table. There are some significant features, the very much important features, or we can say merits of Mendelif's periodic table. Let us discuss all the merits one by one. The first important merit of Mendelif's periodic table, that atomic masses of some elements were revised. Means in the coming years, these elements' atomic masses proved to be changed, and fairly these elements were placed in the correct places in the Mendelif's periodic table. For example, beryllium. The atomic mass of beryllium was previously known 14.09 and then later on it got corrected as 9.4, where Mendelif's periodic table, beryllium is placed in the correct place. Beryllium is placed before boron. The second feature of Mendelif's periodic table, Mendelif kept vacant places in his periodic table and he predicted the atomic masses of elements as 44, 72 and 68. You can see here. he named them Eka boron, Eka silicon and Eka aluminum. And after few years, the same elements got discovered and they were named as scandium, gallium and germanium. In the revised edition of Mendelif's periodic table, there was place given separately in the front group of the group number 1 for inert elements, which were named as zero group elements. Without disturbing the whole periodic table, these zero group elements were placed in the Mendelif's periodic table after the discovery. Let us discuss demerits of Mendelif's periodic table. The whole number of atomic masses of an element like cobalt and nickel same, and there was ambiguity about the sequence of these elements. Cobalt and nickel, their atomic masses were 15 and 59. There was confusion which element has to be placed first, cobalt or nickel. So this was the first demerit of Mendelif's periodic table. Mendelif's periodic table was not able to give the separate place for both the elements, and since atomic masses were same, they were placed in the same place. The second demerit, isotopes. Isotopes were discovered long time after the explanation of Mendelif's periodic table, and by the periodic law on which the Mendelif's periodic was based, isotopes have to be placed in separate places, but it was not possible in the Mendelif's periodic table. So that was the second demerit of Mendelif's periodic table. The third important demerit of Mendelif's periodic table. As elements are placed in the increasing order of atomic masses, there should be the uniformity in the arrangement of atomic masses, but it was not observed. Means between the two elements, the difference of atomic mass, some places was less and some places it was more. For example, the difference between atomic masses of sodium and magnesium. Sodium has 23 and magnesium has 24. Right? This is very less difference. Consider the atomic mass difference between nitrogen and oxygen. Nitrogen has 14 while oxygen has 16. The same way you can see the difference between the atomic masses of chromium and manganese. Atomic mass of chromium is 52 while that of manganese is 55. There is the difference of 3. So this is the demerit of Mendelif's periodic table. The next demerit of Mendelif's periodic table is position of hydrogen. Hydrogen shows the similarity with the first group elements as well as group 7 elements, halogens. Molecular formula of hydrogen, it is H2, which is similar to that of the halogen, like Cl2, Br2, I2. Means it is showing some similarity of chemical property with the halogens. But chemical properties of hydrogen are matching with the group 1 elements like sodium, potassium. And on the other hand, molecular formula of hydrogen is H2 like Cl2. There was the problem of placing of hydrogen, whether it has to be placed in the first group or to be placed in the 7th group with halogens. So the Mendelif's periodic table was not able to answer some more doubts. And as the science progressed, Mendelif's periodic table was also got changed. And today we know about modern periodic table, but it is based on Mendelif's periodic table. So dear students, we will learn about modern periodic table in the next period. Dear students, before ending the class, let us answer these two questions.